In many desktop video players, you can scrub the timeline to navigate a video and see the frames update in real time. In contrast, online streaming video players do not typically support scrubbing, since frames are requested and downloaded from the server as needed, creating a considerable amount of latency while dragging the slider. An exception is the Netflix video player, which does support real-time scrubbing of thumbnails, but the thumbnails can take a considerable time to load. To quantify the effects of latency on video navigation tasks, we ran a study using abstracted video content to simulate 3 classifications of video types for navigation. In a sequential video, the scenes have a natural order, which is known to the viewer. An example is a televised sporting event with a game clock visible in the corner. In this study, users needed to find the scene in the video where the square with the black dot faded in. During an ordered video, it is possible for the viewer to tell if they are before or after the target scene, but not how far away from it they are. An example of this task is navigating through a commercial break to get back to the television show. Finally, in a random video, the viewer does not know where their target scene is likely to be located. An example of this type of task is finding a particular scene in a movie you have never seen before. We tested degrees of latency from 0 milliseconds up to 1000 milliseconds, and also a condition with 0 milliseconds of latency where a low-resolution version of the video was displayed. Overall, the task completion time increased as latency increased, but of particular interest is the large drop in performance between 0 milliseconds and 20 milliseconds. To address the issue of latency, we present Swift, a technique that supports real-time scrubbing of online videos by overlaying a low-resolution copy of the video during scrubbing, and snapping back to the high-resolution video when scrubbing is complete. We performed a second experiment to evaluate the Swift technique against traditional online video players, using a collection of realistic live motion videos and content-specific search tasks. In general, we see the Swift technique outperforming the traditional player, and in some cases, decreasing completion time by as much as 72% in the 500 millisecond condition. Finally, the Swift technique can be easily implemented with less than 30 lines of JavaScript and HTML5 code, making it suitable for use in today's modern web browsers.